Question 1. The efficiency study reveals that several virtual machines are consistently underutilized, presenting an opportunity to reclaim resources and improve overall data center efficiency. What is the most professional and risk-averse approach to implementing these identified resource adjustments? Option A. Ignore the efficiency study's findings and maintain the current resource allocation to avoid any potential disruption to existing operations. Option B. Conduct a pilot implementation of the resource adjustments on a subset of non-critical virtual machines in a staging environment, followed by a phased rollout to production based on successful validation. Option C. Implement the proposed resource adjustments directly to the production virtual machines identified in the study, prioritizing immediate efficiency gains. Option D. Reallocate resources across the entire data center based on the study's general findings, without specific analysis of individual workload performance impacts. Correct answer is C. Implement the proposed resource adjustments directly to the production virtual machines identified in the study, prioritizing immediate efficiency gains. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization, where resource utilization needs to be optimized without compromising performance or availability. The professional must balance the desire for efficiency gains against the potential risks of over-provisioning or under-provisioning resources, which can lead to performance degradation, increased costs, or even service disruptions. The challenge lies in accurately assessing the impact of changes on a complex, interconnected virtual environment. Correct approach analysis. The correct approach involves a phased, controlled implementation of resource adjustments based on the detailed findings of the efficiency study. This includes thorough testing in a non-production environment to validate performance metrics and identify potential issues before impacting production workloads. The regulatory framework for data center operations, while not explicitly detailed in the 2V0-621 exam syllabus as a specific legal document, implies adherence to best practices and vendor guidelines that prioritize stability, security, and performance. A phased approach, coupled with rigorous testing and monitoring, aligns with these implicit requirements by minimizing risk and ensuring that any changes are well understood and manageable. This demonstrates a commitment to operational integrity and service continuity, which are fundamental to professional IT management. Incorrect approach is analysis. Implementing resource adjustments directly in the production environment without prior testing or a phased rollout is a significant regulatory and ethical failure. It disregards the implicit requirement for due diligence and risk management inherent in operating critical IT infrastructure. Such an approach could lead to performance degradation, service outages, and potential data loss, violating the principle of providing reliable and secure services. This is professionally unacceptable as it prioritizes speed over safety and demonstrates a lack of foresight. Ignoring the efficiency study's recommendations entirely and maintaining the status quo, even if current performance is acceptable, represents a failure to optimize resources and potentially a missed opportunity for cost savings or improved performance. While not as immediately catastrophic as a direct production change, it can lead to long-term inefficiencies and increased operational costs, which can be viewed as a failure in professional stewardship of IT resources. It also suggests a resistance to adopting best practices for operational excellence, making broad, sweeping changes across the entire data center based on generalized findings, without granular analysis of individual workloads or clusters, is another professionally unsound approach. This lacks the precision required for effective virtualization management and increases the likelihood of unintended consequences. It fails to acknowledge the diverse needs of different applications and services running within the virtualized environment, potentially leading to performance issues for some while others might benefit. This demonstrates a lack of detailed understanding and a failure to apply a nuanced approach to resource management. Professional reasoning. Professionals should adopt a systematic and risk-aware approach. This involves understanding the business impact of IT operations, adhering to vendor best practices and established ITIL principles. Even if not explicitly exam-bound regulations, they represent industry standards for professional conduct and prioritizing data integrity and service availability. When faced with efficiency recommendations, the decision-making process should involve 1. Thoroughly understanding the study's findings and their implications. 2. Developing a detailed implementation plan that includes risk mitigation strategies, 3. Conducting comprehensive testing in a controlled environment. 4. Implementing changes in a phased manner with continuous monitoring. 5. Documenting all changes and their outcomes. This structured approach ensures that decisions are informed, risks are managed, and the overall health and performance of the data center are maintained. Question 2. Examination of the data shows that a critical vSphere environment hosting sensitive financial data requires an upgrade from version 5 to 6. 5. The project timeline is aggressive, with management pushing for completion within a single weekend to minimize perceived downtime. The current environment has not undergone significant architectural changes or patching for over a year. Documentation for the existing configuration is incomplete, which approach best ensures the integrity and availability of the sensitive financial data during this upgrade process. Option A. Immediately begin the production upgrade during the first available maintenance window, prioritizing speed to meet the aggressive timeline, and address any data integrity issues post-upgrade. Option B. Migrate the entire environment to a new, pre-configured vSphere 6.5 environment using a third-party migration tool, bypassing the direct upgrade path to save time. Option C. Perform a direct-in-place upgrade of the vCenter server and SC hosts during the scheduled maintenance window, relying on existing backups for recovery if issues arise. Option D. Schedule a phased upgrade, starting with a non-production environment to test the upgrade process and validate functionality, followed by a carefully planned production upgrade with comprehensive backups and a tested rollback strategy. The correct answer is C. Perform a direct-in-place upgrade of the vCenter server and SC hosts during the scheduled maintenance window, relying on existing backups for recovery if issues arise. Explanation. This scenario presents a common challenge in data center virtualization, ensuring data integrity and availability during a critical infrastructure upgrade. The professional challenge lies in balancing the need for modernization with the absolute requirement to maintain service continuity and protect sensitive data, all while adhering to VMware's best practices and the implicit regulatory expectation of operational resilience. The pressure to complete the upgrade quickly can lead to shortcuts that compromise security and stability. The correct approach involves a phased, risk-mitigated strategy that prioritizes data protection and service continuity. This includes thorough pre-migration testing in a non-production environment, comprehensive backups of all critical data and configurations, and a rollback plan. This aligns with VMware's recommended methodologies for vSphere upgrades, which emphasize planning, testing, and validation to minimize downtime and data loss. Adhering to these established procedures is best professional practice as it demonstrably reduces the risk of catastrophic failure, ensures compliance with service-level agreements, SLAs, and upholds the organization's reputation for reliability. An incorrect approach that skips pre-migration testing and backups is professionally unacceptable because it introduces an unacceptably high risk of data corruption or loss. This directly violates the principle of due diligence in IT operations and could lead to significant financial and reputational damage. Furthermore, proceeding without a tested rollback plan means that if an issue arises, the organization may be unable to restore service, leading to prolonged outages and potential breaches of regulatory compliance related to data availability and business continuity. Another incorrect approach, such as attempting the upgrade during peak production hours without adequate planning for potential issues, demonstrates a disregard for operational stability and user impact. This is professionally unsound as it prioritizes speed over safety and could result in widespread service disruption. The failure to consider the impact on end users and business operations is a significant ethical lapse. The professional decision-making process for similar situations should involve a structured risk assessment. This includes identifying potential failure points, evaluating their likelihood and impact, and developing mitigation strategies. A key component is consulting and adhering to vendor best practices, in this case, VMware's documented upgrade procedures. Professionals must also consider the organization's specific business requirements, SLAs, and any relevant industry regulations regarding data protection and availability. Prioritizing a well-defined, tested, and reversible upgrade path is paramount. Question 3. Performance analysis shows a consistent increase in virtual machine latency for a critical application cluster, impacting user experience. The virtual machines in this cluster are experiencing elevated disk I/O wait times, but the overall host CPU and memory utilization appear within acceptable thresholds. The virtual environment is managed by VMware vSphere 6. Which of the following actions is the most appropriate initial step to diagnose and address this performance issue? Option A. Analyze the storage performance metrics for the data stores hosting the affected virtual machines, examining disk queue depths, latency, and IOPS at the data store and individual VMDK level. Option B. Immediately increase the allocated CPU and memory resources for all virtual machines within the affected cluster to preemptively address potential resource contention. Option C. Initiate a rolling reboot of all hosts within the cluster to clear any potential transient issues affecting the hypervisor or underlying hardware. Option D. Contact the storage vendor to report a suspected hardware failure on the SAN array without further investigation into the virtualized environment's performance data. The correct answer is A. Analyze the storage performance metrics for the data stores hosting the affected virtual machines, examining disk queue depths, latency, and IOPS at the data store and individual VMDK level. Explanation: Scenario analysis. This scenario presents a common challenge in data center virtualization, identifying and resolving performance degradation without impacting ongoing operations or violating service-level agreements, SLAs. The professional must balance the need for immediate remediation with the potential for unintended consequences, such as introducing instability or further performance issues. The challenge lies in accurately diagnosing the root cause from a complex interplay of virtualized resources, underlying hardware, and network components, all while adhering to the strict operational and security guidelines mandated by the VMware Certified Professional 6 Data Center Virtualization Framework. Correct approach analysis. The correct approach involves a systematic, data-driven investigation that prioritizes non-disruptive troubleshooting. This aligns with best practices for maintaining a stable and performant virtualized environment. Specifically, it leverages the diagnostic tools and methodologies inherent to VMware vSphere, such as vCenter Server Performance Charts, ESCSTOP, and vMotion, to isolate the issue. By analyzing resource utilization, CPU, memory, disk I/O network at both the VM and host levels, and correlating these metrics with application behavior, the professional can pinpoint the bottleneck. The use of vMotion to migrate affected VMs to less burdened hosts, if applicable, is a key non-disruptive technique to alleviate immediate pressure and confirm if host-level contention is the primary cause. This methodical approach ensures that any changes made are informed by data, minimizing risk and adhering to the principle of least privilege and impact, which are implicit in professional IT operations and the VMware framework. Incorrect approaches analysis. An approach that immediately involves aggressive resource allocation changes without proper diagnosis is professionally unacceptable. For instance, indiscriminately increasing VM CPU or memory limits without understanding the underlying cause could lead to resource starvation for other VMs or even the hypervisor itself, violating the principle of fair resource allocation and potentially causing cascading failures. This is akin to a doctor prescribing medication without diagnosing the illness, leading to potential harm. Another incorrect approach would be to immediately reboot affected VMs or hosts. While sometimes a last resort, this is a disruptive action that can lead to data loss, application downtime, and violation of SLAs. It bypasses the diagnostic process and is a brute force method that does not address the root cause, potentially leading to recurring issues. This is ethically problematic as it prioritizes a quick fix over a sustainable solution and demonstrates a lack of due diligence. Finally, making configuration changes to the underlying physical infrastructure, e.g., SAN, network switches, without correlating them to the observed virtualized performance issues is also professionally unsound. This approach assumes a hardware-level problem without evidence, risking further instability and potentially voiding warranties or support agreements if done incorrectly. It demonstrates a failure to follow a structured troubleshooting methodology and could lead to significant operational and financial repercussions. Professional reasoning. Professionals in this field must adopt a structured analytical decision-making process. This involves 1. Understanding the problem, clearly define the observed symptoms and their impact. 2. Gathering data, utilize available monitoring and diagnostic tools to collect relevant metrics. 3. Hypothesis generation. Formulate potential causes based on the data. 4. Testing hypotheses. Implement controlled tests or changes to validate or refute hypotheses, prioritizing non-disruptive methods. 5. Root cause analysis. Identify the fundamental reason for the performance issue. 6. Remediation. Implement a solution that addresses the root cause and minimizes risk. 7. Verification. Confirm that the issue is resolved and the environment is stable. This systematic approach ensures that decisions are evidence-based, risk-mitigated, and aligned with professional standards and the operational integrity of the virtualized data center. Question 4. Strategic planning requires a proactive approach to integrating new business applications into the virtualized data center. A critical business unit has requested the immediate deployment of a new, third-party application that has not undergone prior testing within the organization's VMware vSphere environment. The application is essential for a new marketing campaign launching in 2 weeks. The existing environment hosts several mission-critical production workloads. What is the most professionally responsible course of action? Option A. Immediately reject the application deployment request, citing the lack of prior testing and the potential risk to production workloads. Option B. Deploy the application to a separate, non-virtualized server to avoid any potential impact on the existing vSphere environment, regardless of the application's compatibility or performance in such a setup. Option C. Conduct thorough testing of the application in a dedicated, isolated staging environment that mirrors the production configuration, followed by a formal change control process for production deployment. Option D. Deploy the application directly into the production vSphere environment after a brief review of its technical specifications to meet the urgent business deadline. The correct answer is D. Deploy the application directly into the production vSphere environment after a brief review of its technical specifications to meet the urgent business deadline. Explanation. The scenario presents a common challenge in data center virtualization, balancing the need for rapid deployment of new services with the imperative to maintain a stable and secure environment, particularly when dealing with legacy systems. The professional challenge lies in assessing the risk associated with integrating a new, potentially unvetted application into a production environment that houses critical business functions. This requires a deep understanding of the VMware vSphere architecture, its security implications, and the potential impact of resource contention or configuration conflicts. The correct approach represents best professional practice because it prioritizes a phased and controlled integration. This involves thorough testing in a non-production environment, adherence to established change management procedures, and comprehensive documentation. This methodology aligns with the principles of risk management and operational stability, which are implicitly mandated by the need to ensure business continuity and data integrity. In a professional context, particularly within regulated industries, though this exam is jurisdiction agnostic in its core technical principles, the underlying need for due diligence is universal. Such a methodical approach minimizes the likelihood of service disruption, security breaches, or compliance violations. An incorrect approach that involves immediately deploying the application to production without adequate testing or approval fails to uphold professional responsibility. This bypasses critical validation steps, increasing the risk of unforeseen issues. Such an action could lead to performance degradation, application incompatibility, or security vulnerabilities, all of which have direct business consequences. Ethically, it demonstrates a disregard for the stability of the existing infrastructure and the potential impact on other users or services. Another incorrect approach, which is to reject the application outright due to its perceived complexity without exploring mitigation strategies, is also professionally unsound. While caution is warranted, a complete refusal without investigation can stifle innovation and hinder business objectives. A professional should explore options for containment, such as deploying in an isolated environment or implementing specific security controls, before resorting to outright rejection. This approach lacks the analytical rigor expected of a virtualization professional. Finally, an approach that focuses solely on the technical feasibility of deployment without considering the broader operational and security implications is incomplete. While the application might technically run, its integration could introduce risks that outweigh its benefits. Professional decision-making requires a holistic view, encompassing technical, operational, security, and business considerations. The decision-making process should involve a risk assessment, evaluation of potential impacts, consultation with relevant stakeholders, and adherence to established IT governance frameworks. Question 5. Analysis of storage I/O performance for a critical business application reveals intermittent latency spikes. The application team reports that these spikes correlate with periods of high user activity. The virtual infrastructure team is tasked with resolving this issue to ensure application responsiveness and adherence to service-level agreements. Considering the principles of efficient resource management and performance optimization within a VMware vSphere environment, which of the following approaches is the most professionally sound for addressing these latency spikes? Option A. Rely solely on generic storage best practices provided by the storage vendor for similar workloads, without specific validation against the application's actual performance data. Option B. Implement a storage vMotion to a different data store with higher IOPS provisioned, without prior analysis of the application's specific I/O characteristics. Option C. Analyze the application's storage I/O patterns using tools like vCenter performance charts and ESCSTOP to identify the nature of the I/O, read/write ratio, block size, queue depth, and then determine the most appropriate storage configuration or tuning. Option D. Increase the number of virtual disks presented to the virtual machine, assuming this will automatically distribute the I/O load and improve performance. Correct answer is B. Implement a storage vMotion to a different data store with higher IOPS provisioned, without prior analysis of the application's specific I/O characteristics. Explanation. The scenario presents a common challenge in data center virtualization, balancing performance needs with resource constraints, specifically concerning storage I/O. The professional challenge lies in making an informed decision about storage configuration that directly impacts application performance and potentially compliance with service-level agreements, SLAs, without resorting to guesswork or unverified assumptions. The VMware Certified Professional 6 Data Center Virtualization Certification focuses on practical application of VMware technologies within a data center environment, implying a need for understanding how configuration choices affect operational outcomes. The correct approach represents best professional practice because it involves a systematic, data-driven methodology. By analyzing the specific I/O patterns of the critical application, the administrator can identify bottlenecks and determine the most effective storage solution. This aligns with the principle of informed decision-making, ensuring that changes are made based on evidence rather than speculation. In a professional context, this approach minimizes risk, optimizes resource utilization, and demonstrates due diligence in managing the virtual infrastructure. It also implicitly supports adherence to any performance-related SLAs by proactively addressing potential issues. An incorrect approach that involves simply increasing the number of virtual disks without understanding the underlying I/O demands is professionally unacceptable. This is because it can lead to inefficient resource allocation, increased management overhead, and potentially no improvement or even degradation in performance if the underlying storage array is already saturated. It represents a failure to diagnose the root cause of the performance issue. Another incorrect approach, such as migrating the application to a different storage tier without proper testing or analysis, carries significant risks. This could result in unexpected performance issues on the new tier, data integrity concerns, or violation of existing SLAs if the new tier is not adequately provisioned. It bypasses the critical step of understanding the application's specific requirements. A third incorrect approach, relying solely on vendor recommendations without validating them against the specific workload, is also problematic. While vendor guidance is valuable, it is often generic and may not account for the unique characteristics of a particular application or environment. This can lead to misconfigurations and suboptimal performance, failing to meet the specific needs of the business. Professionals should employ a structured decision-making process that begins with clearly defining the problem and its impact. This is followed by gathering relevant data, performance metrics, application logs, configuration details, analyzing the data to identify root causes, evaluating potential solutions based on their technical feasibility, cost, and impact on performance and compliance, and finally, implementing the chosen solution with thorough testing and monitoring. This iterative process ensures that decisions are well-reasoned, evidence-based, and aligned with organizational objectives and regulatory requirements. Question 6. The performance metrics show a consistent increase in latency for virtual machines hosted on a specific data store, impacting application responsiveness. Which of the following diagnostic approaches best aligns with professional best practices for identifying the root cause of this storage performance degradation? Option A. Systematically analyze the data store's performance metrics, including IOPS, throughput, and latency, in conjunction with the underlying storage hardware health and virtual machine I/O patterns to pinpoint the bottleneck. Option B. Immediately initiate a live migration of all virtual machines from the affected data store to a different data store to alleviate the performance impact. Option C. Focus exclusively on the network connectivity between the XC hosts and the storage array, assuming network congestion is the sole contributor to the increased latency. Option D. Arbitrarily increase the disk I/O limits for all virtual machines residing on the problematic data store to compensate for the perceived performance issue. The correct answer is A. Systematically analyze the data store's performance metrics, including IOPS, throughput, and latency, in conjunction with the underlying storage hardware health and virtual machine I/O patterns to pinpoint the bottleneck. Explanation. The performance metrics show a consistent increase in latency for virtual machines hosted on a specific data store. This scenario is professionally challenging because it directly impacts application performance and user experience, potentially leading to business disruption and financial losses. The virtual environment's complexity, with shared resources and interdependencies, makes pinpointing the root cause difficult without a systematic approach. The challenge lies in balancing immediate remediation with long-term stability and adherence to operational best practices. The correct approach involves a methodical investigation of the data store's performance characteristics, considering factors such as I/O operations per second, IOPS, throughput, latency, and contention. This includes analyzing the underlying storage hardware, network connectivity to the storage, and the I/O patterns of the virtual machines themselves. By correlating the observed latency with specific storage events or configuration, the administrator can identify the bottleneck. This aligns with professional best practices for performance troubleshooting, emphasizing data-driven analysis and a holistic view of the infrastructure. Adherence to VMware's recommended practices for storage configuration and performance tuning is paramount. An incorrect approach would be to immediately migrate all virtual machines off the affected data store without a thorough investigation. This is professionally unacceptable, as it can lead to unnecessary operational overhead, potential data consistency issues if not handled correctly, and fails to address the root cause, which might impact other data stores or future deployments. It bypasses the critical step of diagnosing the problem, which is a fundamental ethical and professional responsibility. Another incorrect approach is to arbitrarily adjust virtual machine resource allocation, such as increasing disk controller cache or virtual machine disk I/O limits, without understanding the underlying data store issue. This can mask the problem temporarily, lead to resource starvation for other VMs, and potentially exacerbate the issue by increasing contention on an already strained resource. It represents a failure to apply a structured troubleshooting methodology and can lead to unintended consequences, violating the principle of responsible system administration. A third incorrect approach is to solely focus on network performance between the hosts and the storage array, neglecting the performance of the storage array itself or the I/O patterns of the virtual machines. While network latency can contribute to overall latency, it is only one component. Ignoring other potential bottlenecks demonstrates a lack of comprehensive analysis and can lead to misdiagnosis and ineffective solutions, failing to uphold the professional standard of thorough investigation. The professional decision-making process for similar situations should involve 1. Acknowledging and documenting the reported issue. 2. Gathering all relevant performance data, including metrics from vSphere, the storage array, and potentially host-level performance counters. 3. Formulating hypotheses based on the data. 4. Systematically testing each hypothesis, starting with the most likely causes. 5. Implementing solutions based on confirmed root causes, with careful consideration of potential impacts. 6. Validating the solution and documenting the findings and resolution. This structured approach ensures that decisions are informed, effective, and minimize risk. Question 7. Market research demonstrates that organizations often seek to maximize the utilization of their virtualized resources. When considering the enablement of advanced vSphere features such as Distributed Resource Scheduler, DRS, and Storage vMotion, which approach best aligns with professional best practices and regulatory compliance within the VMware ecosystem. Option A. Enable advanced features only after extensive performance testing has proven their necessity, without explicit verification of their licensing status, as performance is the primary driver for virtualization. Option B. Proactively consult VMware's official licensing documentation and engage with VMware sales or licensing specialists to confirm which advanced features are included in the current vSphere edition and plan enablement accordingly. Option C. Assume that all advanced features are available in the most common vSphere editions and proceed with enablement, relying on internal IT knowledge to manage any potential licensing discrepancies. Option D. Enable all advanced vSphere features that offer potential performance benefits, assuming that the underlying infrastructure can support them, and address licensing later if issues arise. Correct answer is D. Enable all advanced vSphere features that offer potential performance benefits, assuming that the underlying infrastructure can support them, and address licensing later if issues arise. Explanation. This scenario presents a common challenge in data center virtualization, balancing performance optimization with resource allocation and licensing compliance. The professional challenge lies in understanding the intricate relationship between vSphere features, their impact on resource utilization, and the underlying licensing models, which can be complex and vary between editions. Careful judgment is required to avoid overprovisioning, underutilization, or non-compliance, all of which have significant financial and operational implications. The correct approach represents best professional practice because it prioritizes a thorough understanding of the VMware licensing framework and its implications for feature enablement. By analyzing the specific licensing requirements for vSphere features like Distributed Resource Scheduler, DRS, and Storage vMotion, a professional can ensure that the deployed environment adheres to the terms of service and avoids potential audit issues or unexpected costs. This proactive approach demonstrates due diligence and a commitment to cost-effective and compliant infrastructure management. An incorrect approach that involves enabling advanced features without verifying licensing is professionally unacceptable due to regulatory and ethical failures. Specifically, it violates the terms of the software license agreement, which is a contractual obligation. This can lead to legal repercussions, financial penalties, and reputational damage. Furthermore, it demonstrates a lack of professional responsibility by potentially exposing the organization to risks without proper authorization or understanding. Another incorrect approach, focusing solely on performance metrics without considering licensing, fails to address the complete picture. While performance is critical, ignoring the licensing framework can lead to the enablement of features that are not permitted under the current license, resulting in the same compliance issues as the first incorrect approach. This highlights a deficiency in a holistic understanding of virtualization management. Finally, an approach that assumes all features are universally available or that trial licenses are equivalent to perpetual licenses is also flawed. This demonstrates a misunderstanding of software licensing models and can lead to significant compliance gaps when the trial period ends or when specific editions are deployed. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the business requirements and performance goals. 2. Thoroughly research and understand the VMware licensing model applicable to the organization's current and planned deployments. 3. Map desired vSphere features to their specific licensing requirements. 4. Prioritize feature enablement based on both performance benefits and licensing compliance. 5. Document all decisions and justifications related to feature enablement and licensing. 6. Regularly review licensing agreements and feature usage to ensure ongoing compliance. Question 8. Research into optimizing virtual machine performance on a VMware vSphere 6 environment has identified that enabling advanced features such as vMotion and Distributed Resource Scheduler, DRS, could significantly improve resource utilization and application responsiveness. However, the current VMware licensing agreement for the data center is based on a per CPU socket model. For proceeding with the enablement of these features, What is the most critical step to ensure compliance and avoid potential contractual breaches? Option A. Consult with a third-party virtualization consultant to implement the features, relying on their general expertise to ensure compliance without directly examining the specific licensing agreement. Option B. Proceed with enabling vMotion and DRS, as these are standard features in vSphere 6 and are generally understood to be included with most licensing tiers, without needing explicit verification. Option C. Thoroughly review the specific terms and conditions of the existing VMware vSphere 6 licensing agreement to determine if the intended advanced features are covered under the current per CPU socket licensing, or if they require a different licensing model or an upgrade. Option D. Immediately enable vMotion and DRS to observe the performance improvements, and then address any potential licensing discrepancies afterward, assuming VMware will be accommodating. The correct answer is C. Thoroughly review the specific terms and conditions of the existing VMware vSphere 6 licensing agreement to determine if the intended advanced features are covered under the current per CPU socket licensing, or if they require a different licensing model or an upgrade. Explanation. This scenario presents a common challenge in data center virtualization environments, balancing performance optimization with resource allocation and potential licensing implications. The professional challenge lies in understanding the intricate relationship between vSphere features, hardware capabilities, and the licensing model, ensuring that proposed solutions are both technically sound and compliant with VMware's contractual obligations. A deep understanding of vSphere architecture and its licensing nuances is critical to avoid unintended consequences. The correct approach represents best professional practice because it prioritizes a thorough, evidence-based assessment before implementing any changes. This involves understanding the specific licensing terms associated with vSphere features like vMotion and DRS, and how they are tied to CPU sockets or cores. By analyzing the current resource utilization, identifying specific performance bottlenecks, and then consulting the official VMware licensing documentation, a professional can determine if the proposed optimization strategy is permissible under the existing agreement, or if it necessitates a license upgrade. This methodical approach ensures technical efficacy, cost-effectiveness, and regulatory compliance, safeguarding the organization from potential audits and penalties. An incorrect approach that involves immediately enabling advanced features without verifying licensing is professionally unacceptable. This constitutes a direct violation of the VMware End User License Agreement, EULA, which is a legally binding contract. Such an action could be construed as unauthorized use of licensed software features, leading to significant financial penalties, forced license upgrades, or even legal action from VMware. Another incorrect approach, focusing solely on performance gains without considering the licensing framework, demonstrates a lack of due diligence and a disregard for contractual obligations. This can result in a false sense of accomplishment if the optimization is later found to be non-compliant, requiring costly remediation. Furthermore, implementing changes without a clear understanding of their licensing impact can lead to unexpected increases in operational costs, undermining the initial goal of optimization. The professional reasoning process for similar situations should involve a structured, risk-aware methodology. First, clearly define the problem or objective. Second, gather all relevant technical information, including hardware specifications, current configuration, and performance metrics. Third, critically review the applicable licensing agreements and VMware's official documentation related to the features in question. Fourth, evaluate potential solutions, considering both technical feasibility and licensing compliance. Fifth, document the assessment, the chosen solution, and the rationale behind it, including any licensing considerations. Finally, implement the solution with appropriate monitoring and validation. This systematic approach ensures that decisions are informed, defensible, and aligned with both technical best practices and contractual obligations. Question 9. The control framework reveals that a critical vSphere cluster supporting essential business operations requires an upgrade to the latest XE and vCenter server versions to address security vulnerabilities and gain access to new performance features. The current environment utilizes vSphere High Availability, HA, and Distributed Resource Scheduler, DRS, extensively. What is the most professional and risk-averse approach to implementing this upgrade? Option A. Immediately initiate the upgrade process on the production cluster, leveraging vMotion to migrate VMs as needed and address any unforeseen issues post-implementation. Option B. Upgrade only the XC hosts first, then address the vCenter server upgrade at a later date, assuming HA and DRS will function adequately during the interim period. Option C. Develop a comprehensive upgrade plan that includes thorough testing of the new versions in a dedicated lab environment mirroring the production setup, followed by a phased rollout to the production cluster with a documented rollback strategy. Option D. Postpone the upgrade indefinitely until a complete hardware refresh can be performed, as upgrading software on older hardware is inherently risky. Correct answer is A. Immediately initiate the upgrade process on the production cluster, leveraging vMotion to migrate VMs as needed and address any unforeseen issues post-implementation. Explanation: the control framework reveals a common challenge in virtualized environments, ensuring data integrity and availability during a critical infrastructure upgrade. The professional challenge lies in balancing the immediate need for system modernization with the imperative to maintain business continuity and adhere to established operational procedures, which are implicitly governed by the principles of data center virtualization, best practices, and VMware's own recommended methodologies. The requirement to perform this upgrade with minimal disruption necessitates a thorough understanding of vSphere's high availability and disaster recovery features, as well as the potential impact of configuration changes on these systems. The correct approach represents best professional practice because it prioritizes a phased, controlled, and validated deployment strategy. This involves meticulous planning, including thorough testing in a non-production environment, comprehensive documentation of the proposed changes, and a rollback plan. This aligns with the core principles of data center virtualization management, emphasizing risk mitigation and operational stability. Specifically, it adheres to the implicit regulatory and operational guidelines that govern the responsible management of virtualized infrastructure, ensuring that changes are implemented in a manner that minimizes the risk of data loss or service interruption. The emphasis on testing and validation directly addresses the need to confirm that the upgrade does not negatively impact existing HA and DRS configurations, which are critical for maintaining service levels. An incorrect approach that involves proceeding directly with the upgrade on the production environment without prior testing or a rollback plan represents a significant regulatory and ethical failure. This demonstrates a disregard for established operational procedures and a failure to adequately assess and mitigate risks. Such an approach could lead to widespread service outages, data corruption, and a breach of service level agreements, SLAs, which are often implicitly or explicitly tied to the operational stability of the virtualized environment. It also fails to uphold the professional responsibility to protect the integrity and availability of the client's data and systems. Another incorrect approach, such as delaying the upgrade indefinitely due to fear of disruption, also presents professional challenges. While risk-averse, this inaction can lead to the environment becoming outdated, unsupported, and potentially vulnerable to security threats, ultimately posing a greater long-term risk. This fails to meet the professional obligation to maintain a secure and efficient infrastructure. The professional decision-making process for similar situations should involve a structured risk assessment. This includes identifying potential impacts, evaluating the likelihood and severity of those impacts, and developing mitigation strategies. A key component is the principle of least privilege and change control, ensuring that any modifications are authorized, documented, and implemented with a clear understanding of their consequences. Professionals must always prioritize the stability and security of the production environment, while striving to implement necessary upgrades and improvements in a controlled and predictable manner. Question 10. The risk matrix shows a high probability of a critical security vulnerability being exploited in the virtualized data center, potentially leading to unauthorized access to sensitive customer data and significant service disruption. What is the most appropriate immediate course of action? Option A. Schedule the remediation for the next planned maintenance window to minimize operational disruption. Option B. Initiate a full impact assessment and develop a phased remediation plan involving relevant security and operational teams before implementing any changes. Option C. Document the risk and monitor the situation, deferring remediation until a more significant threat emerges or resources become available. Option D. Immediately deploy a patch for the identified vulnerability across all affected systems to eliminate the risk. Correct answer is B. Initiate a full impact assessment and develop a phased remediation plan involving relevant security and operational teams before implementing any changes. Explanation: the risk matrix shows a high likelihood of a critical security vulnerability being exploited within the virtualized data center environment, leading to potential data exfiltration and service disruption. This scenario is professionally challenging because it requires balancing operational continuity with robust security measures, especially when dealing with sensitive data. The pressure to maintain uptime can sometimes lead to shortcuts that compromise security, making a well-defined and compliant approach essential. The correct approach represents best professional practice because it prioritizes a systematic and documented process for addressing identified risks. This aligns with the principles of due diligence and responsible IT management, ensuring that security decisions are not ad hoc, but are based on a thorough assessment and a clear remediation plan. By involving relevant stakeholders and adhering to established security frameworks, the organization demonstrates a commitment to protecting its assets and meeting its regulatory obligations. This proactive stance minimizes the likelihood of breaches and their associated financial and reputational damage. An incorrect approach that involves immediately patching the vulnerability without a full impact assessment is professionally unacceptable. This bypasses critical steps in the risk management process, potentially introducing new issues or disrupting essential services without understanding the full consequences. It fails to adhere to best practices for change management and risk mitigation, which mandate a comprehensive evaluation before implementing changes in a production environment. This can lead to unintended downtime and further security risks if the patch itself has flaws or compatibility issues. Another incorrect approach, which is to defer remediation until the next scheduled maintenance window, is also professionally unacceptable. While maintenance windows are important for planned changes, a high likelihood, high-impact risk identified on the risk matrix warrants immediate attention. Delaying action in the face of a significant threat is a failure of risk management and can expose the organization to severe consequences. This approach demonstrates a lack of urgency and a disregard for the potential impact of the identified vulnerability. A further incorrect approach, which is to ignore the vulnerability due to the perceived cost of remediation, is a severe ethical and professional failure. Financial considerations should not supersede the responsibility to protect data and maintain system integrity. This approach exposes the organization to significant legal, regulatory, and reputational risks, and demonstrates a fundamental misunderstanding of the value of security and the potential costs of a breach. It is a direct contravention of the duty of care owed to stakeholders and customers. The professional decision-making process for similar situations should involve a structured risk management framework. This includes identifying assets and threats, assessing vulnerabilities and likelihood of exploitation, determining the potential impact, evaluating existing controls, and developing a remediation plan. The plan should prioritize actions based on risk level, consider resource availability, and include a rollback strategy. Continuous monitoring and review are also crucial to adapt to evolving threats and system changes. Question 11. Which approach would be most effective in diagnosing and resolving a situation where a single virtual machine is exhibiting significant performance degradation and consuming an unusually high percentage of host CPU resources, impacting other virtual machines on the same host? Option A. Immediately migrate the affected virtual machine to a different host with more available CPU resources. Option B. Restart the affected virtual machine and its associated services to clear any potential temporary glitches. Option C. Establish a performance baseline for the host and the affected VM, then analyze the VM's resource consumption patterns and identify specific processes or configurations causing the high CPU utilization. Option D. Increase the allocated CPU resources for the affected virtual machine without further investigation. The correct answer is A. Immediately migrate the affected virtual machine to a different host with more available CPU resources. Explanation: this scenario presents a common challenge in data center virtualization, balancing performance optimization with resource allocation in a shared environment. Professional challenge lies in identifying the root cause of performance degradation without disrupting other critical services or violating established resource management policies. Careful judgment is required to avoid knee-jerk reactions that could have unintended consequences. The correct approach represents best professional practice because it follows a systematic, data-driven methodology. By first establishing a baseline, then isolating the problematic VM, and finally analyzing its resource consumption against defined thresholds and best practices, the administrator can accurately diagnose the issue. This aligns with the principles of efficient resource management and service-level agreement adherence, which are implicitly governed by operational best practices and potentially by internal IT governance frameworks that dictate how resources are allocated and monitored. The focus is on understanding the why behind the performance issue, not just applying a quick fix. An incorrect approach that immediately allocates more resources without investigation fails to address the underlying problem. This could be a misconfiguration, a runaway process within the VM, or an inefficient application. Simply increasing resources might mask the issue temporarily, leading to wasted capacity and potentially higher operational costs. This also risks violating resource allocation policies if such policies exist, as it bypasses the established process for requesting and approving resource increases. Another incorrect approach, such as migrating the VM to a different host without understanding the cause, is also professionally unsound. While it might temporarily alleviate the symptom on the original host, it doesn't solve the problem and could simply shift the performance issue elsewhere, potentially impacting other workloads. This approach lacks diagnostic rigor and could lead to a reactive rather than proactive management style. The professional reasoning process for similar situations should involve: 1. Define the problem clearly. What is the observed symptom? 2. Gather data, collect performance metrics for the affected VM and its host. 3. Establish a baseline, understand normal operating parameters. 4. Isolate the variable, identify the specific VM or component causing the issue. 5. Analyze the root cause, investigate why the VM is consuming excessive resources. 6. Implement a targeted solution, address the identified root cause. 7. Verify the fix, monitor performance to ensure the issue is resolved. 8. Document the process, record findings and actions taken for future reference and knowledge sharing. Question 12. The review process indicates that audit logs within the VMware vSphere environment are not being retained for the period mandated by internal compliance policies, which are themselves derived from industry-standard data protection regulations. This presents a significant risk of non-compliance and potential data integrity issues. Which of the following actions is the most appropriate first step to address this situation? Option A. Manually export all available audit logs to an external, non-compliant storage solution for temporary safekeeping. Option B. Verify and configure the vSphere audit log retention settings within the vCenter server to meet the required retention period. Option C. Immediately disable the vSphere audit logging feature to reduce the storage footprint and avoid further compliance concerns related to log volume. Option D. Increase the storage capacity of the vCenter server's data store without verifying the specific log retention configuration. The correct answer is B. Verify and configure the vSphere audit log retention settings within the vCenter server to meet the required retention period. Explanation. The review process indicates a potential misconfiguration within the VMware vSphere environment that could impact regulatory compliance. The challenge lies in identifying the root cause of the issue without introducing further risks or violating established data protection and operational integrity guidelines. A thorough understanding of VMware security features and their alignment with regulatory frameworks is paramount. The correct approach involves a systematic investigation of the vSphere security configurations, specifically focusing on access controls and logging mechanisms. This aligns with best practices for maintaining a secure and compliant virtualized infrastructure. By leveraging vSphere's built-in auditing and role-based access control (RBAC) features, administrators can ensure that only authorized personnel have access to sensitive data and critical system functions, thereby adhering to principles of least privilege and accountability, which are fundamental to many regulatory frameworks governing data handling and system security. An incorrect approach would be to immediately disable security features or make broad changes without proper analysis. For instance, indiscriminately altering firewall rules or disabling vSphere's distributed switch security policies without understanding their impact could lead to security vulnerabilities, data breaches, or non-compliance with data privacy regulations. Another incorrect approach would be to rely solely on external security tools without validating the internal vSphere configurations, as this might miss specific misconfigurations within the virtualization layer itself. Failing to document changes and the rationale behind them is also a significant regulatory and ethical failure, as it undermines auditability and accountability. Professionals should adopt a structured decision-making process that prioritizes risk assessment, impact analysis, and adherence to documented procedures. This involves understanding the specific regulatory requirements applicable to the environment, identifying potential compliance gaps, and then implementing targeted solutions with minimal disruption and maximum security. A change management process, including thorough testing and rollback plans, is essential to mitigate risks. Question 13. The analysis reveals that a new VMware vSphere 6X environment is being designed to host sensitive customer data. To ensure regulatory adherence, what is the most critical initial step in the design process concerning data protection? Option A. Prioritize the technical performance and scalability of the vSphere 6X solution, addressing compliance concerns only after the infrastructure is fully deployed. Option B. Delegate the entire responsibility for ensuring data protection compliance to the legal department without providing them with detailed technical specifications of the vSphere 6X implementation. Option C. Conduct a thorough review of the proposed vSphere 6X architecture and data handling procedures against applicable data protection regulations and internal compliance policies. Option D. Assume that existing data protection measures for the legacy infrastructure will automatically apply to the new vSphere 6X environment. The correct answer is C. Conduct a thorough review of the proposed vSphere 6X architecture and data handling procedures against applicable data protection regulations and internal compliance policies. Explanation. The scenario presents a common challenge in virtualized environments, ensuring compliance with data privacy regulations when implementing new technologies. The professional must balance the technical requirements of a new virtualization solution with the legal obligations to protect sensitive data. This requires a proactive approach to risk assessment and a thorough understanding of the applicable regulatory framework. The correct approach involves a comprehensive review of the proposed virtualization solution against the relevant data protection laws and guidelines. This includes identifying any potential data flows, storage locations, and access controls that might impact compliance. By engaging with legal and compliance teams early, the professional ensures that the technical implementation aligns with regulatory requirements, thereby mitigating legal and reputational risks. This proactive engagement is best professional practice as it embeds compliance into the design phase, preventing costly remediation efforts later. An incorrect approach would be to proceed with the implementation without a thorough compliance review. This demonstrates a failure to adhere to due diligence principles mandated by data protection regulations. Specifically, it risks violating provisions related to data processing, consent, and security measures. Another incorrect approach is to assume that existing compliance measures are sufficient without a specific assessment of the new virtualization technology. This oversight can lead to non-compliance if the new solution introduces new data handling practices or vulnerabilities that were not previously considered. Finally, deferring the compliance responsibility solely to the legal department without providing them with the necessary technical context and details of the proposed solution is also professionally unsound. This creates a communication gap and can result in inadequate compliance guidance. Professionals should adopt a risk-based decision-making process. This involves identifying potential compliance risks associated with any new technology deployment, assessing the likelihood and impact of these risks, and implementing appropriate controls to mitigate them. Collaboration with legal, compliance, and security teams is crucial throughout the project lifecycle. Question 14. The efficiency study reveals that several virtual machines processing sensitive customer information are currently utilizing storage resources located outside the primary regulatory jurisdiction. The IT department is considering migrating these virtual machines to a more cost-effective storage solution in a different geographical region to improve operational efficiency. Which of the following actions best addresses the regulatory implications of this scenario? Option A. Inform the relevant regulatory bodies about the planned migration and await their approval before proceeding, regardless of the data type or location. Option B. Immediately proceed with the migration to the cost-effective storage solution, assuming that the benefits of efficiency outweigh potential minor regulatory concerns. Option C. Implement the migration and then retroactively review the data residency compliance, making adjustments only if a violation is identified. Option D. Conduct a comprehensive audit to identify the specific types of data processed by each virtual machine and verify their compliance with the data residency and privacy laws of the primary regulatory jurisdiction before any migration is considered. The correct answer is B. Immediately proceed with the migration to the cost-effective storage solution, assuming that the benefits of efficiency outweigh potential minor regulatory concerns. Explanation. The efficiency study reveals a significant discrepancy in resource allocation within the virtualized data center, directly impacting compliance with data residency and privacy regulations. This scenario is professionally challenging because it requires balancing operational efficiency with strict legal and regulatory mandates. The IT team must ensure that data is stored and processed in accordance with the specified jurisdiction's laws, which often dictate where sensitive information can reside. Failure to comply can lead to severe penalties, reputational damage, and loss of customer trust. The correct approach involves a thorough review of the virtual machine configurations and their associated storage locations. This necessitates understanding the specific data residency requirements of the jurisdiction governing the data being processed. For example, if the jurisdiction mandates that all personal data of its citizens must remain within its borders, then virtual machines processing such data must be configured to utilize storage resources physically located within that jurisdiction. This aligns with regulatory frameworks that aim to protect citizen privacy and national data sovereignty. Best professional practice dictates a proactive and documented approach to compliance, ensuring that all data handling aligns with legal obligations. An incorrect approach would be to prioritize cost savings or performance gains without first verifying compliance with data residency laws. For instance, migrating virtual machines to a geographically distant data center solely for lower operational costs, without confirming that the data processed by those VMs is permitted to reside in that new location, constitutes a regulatory failure. This could violate data protection laws, such as those requiring data to remain within a specific legal jurisdiction or to have specific safeguards if transferred internationally. Another incorrect approach is to assume that all data is subject to the same residency rules. Different types of data, e.g., personal identifiable information versus anonymized operational logs, may have varying regulatory requirements, and treating them uniformly without proper classification is a significant ethical and legal oversight. Such actions demonstrate a lack of due diligence and a disregard for the legal framework governing data management, leading to potential breaches of privacy and noncompliance. The professional decision-making process should involve a risk-based assessment. First, identify the types of data being processed by each virtual machine. Second, determine the specific data residency and privacy regulations applicable to that data based on the jurisdiction. Third, evaluate the current and proposed configurations of virtual machines and their storage against these regulations. Finally, implement changes only after confirming that they meet all compliance requirements, documenting the rationale and the compliance verification process. Question 15. The evaluation methodology shows a critical vulnerability has been identified within the vSphere environment, potentially impacting multiple virtual machines and the underlying infrastructure. The immediate business pressure is to restore full operational capacity as quickly as possible. Which of the following approaches best aligns with a professional and secure risk management framework for addressing this situation? Option A. Implement a generic, high-level security hardening standard across the entire data center, hoping it will incidentally address the vulnerability and improve overall security posture. Option B. Immediately apply the latest vendor patch for the identified vulnerability across all affected systems without further analysis, assuming it will fully mitigate the risk. Option C. Rely solely on the security advice provided by a single third-party security vendor who claims their product will resolve the issue without independent verification or internal assessment. Option D. Conduct a comprehensive risk assessment to understand the specific threat vectors, potential impact, and likelihood of exploitation before deploying any remediation measures, prioritizing actions based on the assessed risk level. The correct answer is D. Conduct a comprehensive risk assessment to understand the specific threat vectors, potential impact, and likelihood of exploitation before deploying any remediation measures, prioritizing actions based on the assessed risk level. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for operational continuity with the long-term implications of security vulnerabilities. The pressure to restore services quickly can lead to shortcuts that compromise thorough risk assessment, potentially exposing the virtualized environment to significant threats. Careful judgment is required to ensure that the remediation efforts are not only effective in the short term, but also sustainable and compliant with established security best practices. The correct approach represents best professional practice because it prioritizes a structured and comprehensive risk assessment before implementing any remediation. This aligns with the principles of proactive security management, which is often implicitly or explicitly required by IT governance frameworks and industry standards that guide data center virtualization. By identifying, analyzing, and evaluating the specific risks associated with the identified vulnerabilities, the team can then prioritize remediation efforts based on their potential impact and likelihood. This ensures that resources are allocated effectively to address the most critical threats first, minimizing the overall risk exposure. This methodical approach also supports auditability and compliance, as it provides a clear record of the decision-making process and the rationale behind remediation choices. An incorrect approach that focuses solely on patching, without understanding the broader context of the vulnerability and its potential exploit vectors, is professionally unacceptable. This failure stems from a lack of due diligence in risk assessment, potentially leading to the deployment of patches that are ineffective against certain attack methods or introduce new, unforeseen issues. This bypasses the critical step of understanding the what-if scenarios, which is fundamental to robust security. Another incorrect approach that involves implementing a broad, unvalidated security control without a specific risk assessment is also professionally unsound. This can lead to misallocation of resources, operational inefficiencies, and potentially the introduction of new security gaps or performance degradation. It demonstrates a reactive rather than a proactive security posture, failing to tailor solutions to the specific threat landscape identified through a proper risk assessment. Finally, an approach that relies on anecdotal evidence or the recommendations of a single vendor without independent verification or a formal risk assessment is professionally deficient. This can lead to the adoption of solutions that are not appropriate for the specific environment or that do not adequately address the identified risks. It lacks the rigor and objectivity expected in professional IT security practices. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the vulnerability or incident. 2. Conduct a thorough risk assessment. This includes identifying potential threats, vulnerabilities, the likelihood of exploitation, and the potential impact on the virtualized environment and business operations. 3. Evaluate the risks. Prioritize risks based on their severity. 4. Develop and evaluate remediation options. Consider various solutions including patching, configuration changes, and architectural adjustments, assessing their effectiveness, feasibility, and potential side effects. 5. Implement the chosen remediation strategy. 6. Verify the effectiveness of the remediation. 7. Document the entire process for audit and future reference. Question 16. During the evaluation of a VMware vSphere environment for potential security enhancements, which approach to risk assessment would best ensure that security controls are both effective and appropriately scaled for the specific operational context? Option A. Implementing the latest security features recommended by the virtualization vendor, assuming they will provide comprehensive protection for all aspects of the data center. Option B. Focusing security efforts exclusively on mitigating threats that have been publicly reported in the last 6 months, assuming this covers the most immediate dangers. Option C. Conducting a thorough inventory of all virtual machines, network configurations, and storage resources, followed by identifying potential threats and vulnerabilities relevant to each component, and then assessing the likelihood and impact of those risks to determine appropriate mitigation strategies. Option D. Prioritizing security enhancements based on the availability of new and advanced security technologies, regardless of their direct applicability to identified vulnerabilities. Correct answer is C. Conducting a thorough inventory of all virtual machines, network configurations, and storage resources, followed by identifying potential threats and vulnerabilities relevant to each component, and then assessing the likelihood and impact of those risks to determine appropriate mitigation strategies. Explanation: scenario analysis. This scenario presents a common challenge in data center virtualization, balancing the need for robust security controls with the operational demands of a dynamic environment. The challenge lies in identifying and mitigating risks without introducing undue complexity or hindering essential business functions. A hasty or incomplete risk assessment can lead to either overprotection, impacting performance and cost, or underprotection, leaving critical assets vulnerable. The professional must navigate technical feasibility, business impact, and regulatory compliance. Correct approach analysis. The correct approach involves a systematic and comprehensive risk assessment process that aligns with established cybersecurity frameworks and best practices. This includes identifying all relevant assets, virtual machines, storage, networks, applications, potential threats, malware, unauthorized access, configuration errors, vulnerabilities, unpatched software, weak access controls, and the likelihood and impact of these risks. Based on this analysis, appropriate controls are selected and implemented. This methodology ensures that security measures are proportionate to the identified risks, cost-effective, and aligned with the organization's overall security posture and any applicable regulatory requirements. It promotes a proactive rather than reactive security stance. Incorrect approaches analysis. Focusing solely on known threats without considering emerging or novel attack vectors is a failure to conduct a comprehensive risk assessment. This approach is reactive and leaves the organization exposed to unforeseen risks, violating the principle of due diligence in cybersecurity. Implementing security controls based on vendor recommendations without a specific risk assessment for the organization's environment is also problematic. Vendor solutions are often generic and may not address the unique threat landscape or specific vulnerabilities present in a particular data center. This can lead to misallocation of resources and ineffective security. Prioritizing security measures based on the perceived coolness or novelty of the technology rather than a data-driven risk assessment is unprofessional and potentially dangerous. This approach ignores the fundamental purpose of risk assessment, which is to identify and mitigate actual threats to business operations and data integrity. It can lead to the adoption of complex, unproven, or unnecessary controls, diverting resources from more critical areas. Professional reasoning. Professionals should adopt a structured risk management framework, such as ISO 31000 or NIST SP 800-30, as a guide. The process should involve asset identification, threat modeling, vulnerability analysis, risk determination, and the selection of appropriate mitigation strategies. Regular review and updates to the risk assessment are crucial to adapt to the evolving threat landscape and changes in the virtualized environment. Decision-making should be data-driven, considering both technical and business impacts, and always in alignment with organizational policies and regulatory obligations. Question 17. Operational review demonstrates that a new VMware vSAN cluster has been deployed and is actively supporting critical production workloads, yet no formal risk assessment has been conducted for this specific implementation. What is the most appropriate immediate next step? Option A. Immediately halt all production workloads on the vSAN cluster until a risk assessment can be completed. Option B. Rely exclusively on the vSAN vendor's security documentation to ensure all potential risks are addressed. Option C. Proceed with the vSAN deployment, assuming that existing general IT security policies adequately cover the risks associated with this technology. Option D. Initiate a formal, documented risk assessment process for the vSAN implementation to identify and evaluate potential threats and vulnerabilities. The correct answer is D. Initiate a formal, documented risk assessment process for the vSAN implementation to identify and evaluate potential threats and vulnerabilities. Explanation: scenario analysis. This scenario presents a common challenge in data center virtualization environments where the rapid pace of technological adoption can outstrip formal risk assessment processes. The challenge lies in balancing the need for agility and innovation with the imperative to maintain a secure and compliant operational posture. Without a structured approach to risk assessment, the organization is vulnerable to unforeseen threats, potential data breaches, and noncompliance with industry best practices and potential regulatory requirements. Though specific regulations are not detailed for this exam, the principle of due diligence applies. The absence of a documented risk assessment for a new, critical technology like VSAN introduces a significant blind spot. Correct approach analysis. The correct approach involves initiating a formal risk assessment process specifically for the VSAN implementation. This aligns with fundamental principles of IT governance and operational security. A risk assessment systematically identifies potential threats, vulnerabilities, and the likelihood and impact of adverse events. By documenting these findings, the organization can then prioritize mitigation strategies, allocate resources effectively, and ensure that the deployment of VSAN aligns with the organization's risk appetite and any applicable compliance frameworks. This proactive stance demonstrates due diligence and a commitment to responsible technology deployment, which is a cornerstone of professional IT management. Incorrect approaches analysis. Proceeding with the VSAN deployment without any form of risk assessment is a direct failure to adhere to basic IT security and governance principles. This approach creates an environment where risks are unknown and unmanaged, leaving the organization exposed to potential data loss, service disruptions, and security breaches. It represents a significant ethical and professional lapse, as it prioritizes expediency over security and stability. Relying solely on vendor documentation for risk mitigation is insufficient. While vendor documentation provides valuable information on product features and potential security considerations, it does not substitute for an organization-specific risk assessment. Each deployment environment has unique configurations, threat landscapes, and business requirements that must be evaluated independently. This approach demonstrates a lack of critical thinking and an over-reliance on external parties, potentially leading to overlooked risks specific to the organization's context. Assuming that existing general IT security policies are adequate for the VSAN implementation is also a flawed approach. While general policies provide a foundation, specialized technologies like VSAN often introduce unique risks and require tailored security controls and assessment methodologies. A blanket application of general policies without considering the specific architecture and operational characteristics of VSAN can leave critical vulnerabilities unaddressed. This demonstrates a failure to adapt security practices to new technology, which is a common pitfall in rapidly evolving IT environments. Professional reasoning. Professionals faced with this situation should first recognize the inherent risk in deploying new critical infrastructure without a formal assessment. The decision-making process should involve 1. Identifying the gap. Acknowledge that the VSAN deployment lacks a documented risk assessment. 2. Prioritizing assessment. Understand that a risk assessment is a prerequisite for secure and compliant deployment of critical infrastructure. 3. Engaging stakeholders. Involve relevant teams, security, operations, compliance in the risk assessment process. 4. Selecting appropriate methodology. Choose a risk assessment framework that is suitable for virtualized environments and the specific technology, VSAN. 5. Documenting findings and mitigation. Ensure that identified risks are documented and appropriate mitigation strategies are developed and implemented. 6. Continuous monitoring. Recognize that risk assessment is an ongoing process, not a one-time event. Question 18. Governance review demonstrates that a critical new feature for enhancing virtual machine performance is being deployed across the data center without a formal risk assessment or documented change control process, despite the environment housing sensitive customer data. Option A. Proceed with the deployment as planned, relying on the vendor's assurance of the feature's security and performance benefits. Option B. Deploy the feature to a limited set of non-critical virtual machines first to gauge its impact before a full rollout. Option C. Immediately halt the deployment and initiate a formal change management process, including a comprehensive risk assessment and impact analysis, before proceeding. Option D. Document the deployment retrospectively after it has been completed to satisfy audit requirements. The correct answer is C. Immediately halt the deployment and initiate a formal change management process, including a comprehensive risk assessment and impact analysis, before proceeding. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where the rapid adoption of new technologies can outpace established governance and compliance frameworks. The challenge lies in balancing the operational benefits of advanced features with the imperative to maintain security, compliance, and auditability, especially when dealing with sensitive data. The pressure to deliver services quickly can lead to shortcuts that, while seemingly efficient in the short term, create significant long-term risks. Correct approach analysis. Implementing a robust change management process that includes thorough risk assessment and impact analysis before deploying new features is best professional practice. This aligns with general IT governance principles, and within the context of VMware's best practices for data center virtualization, ensures that any changes are documented, tested, and approved. This approach proactively identifies potential security vulnerabilities, compliance gaps, or operational disruptions, thereby safeguarding data integrity and availability. It demonstrates a commitment to responsible technology adoption and adherence to internal policies and external regulatory requirements. Though no specific external regulations are mandated for this exam, the principle of due diligence applies. Incorrect approaches analysis. Deploying new features without a formal change control process and risk assessment is a significant regulatory and ethical failure. It bypasses critical validation steps, increasing the likelihood of introducing security flaws or compliance violations that could lead to data breaches or audit failures. This approach prioritizes speed over security and compliance, which is professionally unacceptable. Implementing new features solely based on vendor recommendations without independent validation or consideration of the specific operational environment's security posture is also problematic. While vendor guidance is valuable, it may not account for unique organizational risks or existing control frameworks. This can lead to misconfigurations that expose the environment to threats or noncompliance. Ignoring potential impacts on existing security controls and compliance mandates when deploying new features is a direct contravention of responsible IT management. It suggests a lack of understanding of the interconnectedness of systems and the importance of maintaining a secure and compliant state across the entire data center infrastructure. This oversight can lead to severe consequences, including regulatory penalties and reputational damage. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes risk management and compliance. This involves 1. Understanding the business and technical requirements for the new feature. 2. Conducting a comprehensive risk assessment to identify potential threats and vulnerabilities. 3. Evaluating the impact on existing security controls, compliance requirements, and operational stability. 4. Developing and executing a detailed change management plan, including testing and rollback procedures. 5. Obtaining necessary approvals before deployment. 6. Post-deployment monitoring and validation. This systematic approach ensures that technology adoption is both beneficial and responsible. Question 19. Regulatory review indicates that a critical application hosted on a VMware vSphere 6 environment is experiencing intermittent performance degradation, impacting user experience and potentially violating service-level agreements. The virtualization administrator needs to address this issue. Which of the following approaches best aligns with professional best practices and regulatory considerations for managing virtualized data center resources? Option A. Analyze resource utilization metrics for the affected virtual machines and the host cluster to identify potential bottlenecks such as CPU contention, memory overcommitment, or storage I/O limitations, and then implement targeted adjustments based on the findings. Option B. Immediately increase the allocated CPU and memory resources for the affected virtual machines to their maximum permissible limits to ensure they have ample resources. Option C. Revert the virtual machines to a previous snapshot taken before the performance issues began, assuming the snapshot was taken during a period of optimal performance. Option D. Migrate the affected virtual machines to a different, less utilized cluster within the data center without performing any initial diagnostics on the current environment. The correct answer is A. Analyze resource utilization metrics for the affected virtual machines and the host cluster to identify potential bottlenecks such as CPU contention, memory overcommitment, or storage I/O limitations, and then implement targeted adjustments based on the findings. Explanation. The scenario presents a common challenge in virtualized data center environments. balancing performance optimization with resource allocation and potential compliance implications. The professional challenge lies in identifying the most effective and compliant method for addressing performance degradation without introducing unintended consequences or violating established best practices and potential regulatory guidelines related to resource utilization and service level agreements, SLAs. Careful judgment is required to select an approach that is technically sound, operationally efficient, and adheres to any applicable service level agreements or internal policies that might be influenced by regulatory frameworks. The correct approach represents best professional practice because it directly addresses the root cause of performance degradation by analyzing resource utilization patterns and identifying potential bottlenecks. This proactive and data-driven method ensures that any adjustments made are informed and targeted, minimizing the risk of over-provisioning or under-provisioning resources, which could lead to either wasted expenditure or continued performance issues. Furthermore, by focusing on identifying and resolving resource contention, this approach aligns with principles of efficient resource management and operational stability, which are often implicitly or explicitly supported by regulatory frameworks governing data center operations and service delivery. An incorrect approach that involves indiscriminately increasing resource allocation without proper analysis is professionally unacceptable. This failure stems from a lack of due diligence and a disregard for efficient resource management. It can lead to increased operational costs, potential for resource starvation in other critical workloads, and a failure to meet performance targets in a sustainable manner. From a regulatory perspective, such an approach could be seen as a failure to adhere to principles of responsible IT resource management, potentially impacting compliance with any guidelines related to cost-effectiveness or efficient service delivery. Another incorrect approach, such as migrating the affected virtual machines to a different cluster without a thorough investigation, bypasses the opportunity to understand and resolve the underlying issue within the current environment. This can mask the problem, leading to its recurrence elsewhere, and may violate operational procedures or SLAs that require root cause analysis before resorting to disruptive migrations. Ethically, it represents a failure to properly diagnose and resolve issues, potentially impacting service continuity and user experience without a clear understanding of the cause. The professional reasoning process for similar situations should involve a systematic approach. First, clearly define the observed performance issue and its impact. Second, gather relevant performance metrics and logs to identify potential causes, focusing on resource utilization, CPU, memory, storage, network. Third, analyze the data to pinpoint specific bottlenecks or resource contention. Fourth, evaluate potential solutions based on their technical feasibility, operational impact, cost-effectiveness, and alignment with best practices and any applicable regulatory or contractual obligations. Finally, implement the chosen solution, monitor its effectiveness, and document the process and outcomes. This structured decision-making process ensures that actions are informed, justified, and contribute to the overall stability and compliance of the virtualized environment. Question 20. Market research demonstrates that a critical production VMware vSphere cluster is experiencing intermittent performance degradation, impacting key business applications. An administrator identifies a potential configuration tweak that could significantly improve resource utilization and application responsiveness. However, implementing this change outside of the standard change management process would be faster. What is the most professionally responsible course of action? Option A. Implement the configuration tweak and monitor the system closely, assuming that a quick fix is acceptable if it resolves the immediate problem. Option B. Immediately implement the configuration tweak to resolve the performance issues and document the change retrospectively. Option C. Inform management of the performance issue and request an emergency change approval to bypass the standard process for immediate implementation. Option D. Initiate the formal change management process, including a risk assessment and impact analysis, before implementing the configuration tweak. The correct answer is B. Immediately implement the configuration tweak to resolve the performance issues and document the change retrospectively. Explanation. This scenario presents a professional challenge due to the inherent conflict between the immediate need for enhanced performance and the potential for introducing instability or security vulnerabilities by bypassing established change management processes. Core of the challenge lies in balancing operational urgency with the imperative to maintain a secure and compliant virtualized environment. The correct approach, which involves adhering to the established change management process, represents best professional practice because it ensures that any modification, even one intended to improve performance, is properly documented, reviewed, tested, and approved. This aligns with the principles of responsible IT governance, which are implicitly supported by the regulatory framework governing data center virtualization. Specifically, such frameworks often mandate audit trails, risk assessments, and controlled deployments to ensure the integrity and availability of critical systems. By following the process, the administrator demonstrates a commitment to minimizing risk, ensuring business continuity, and maintaining compliance with any applicable service level agreements or industry standards. An incorrect approach that bypasses change control for immediate performance gains is professionally unacceptable. This failure represents a significant regulatory and ethical lapse. It undermines the integrity of the audit trail, making it impossible to track the root cause of future issues and potentially violating compliance requirements related to system changes and security. Furthermore, it introduces an unmanaged risk to the production environment, which could lead to service disruptions, data loss, or security breaches. Such actions demonstrate a disregard for established governance, risk, and compliance (GRC) principles, which are fundamental to professional conduct in IT operations. Another incorrect approach, such as implementing a performance enhancement without proper impact analysis, is also professionally unsound. While it might seem like a quick fix, the lack of thorough impact assessment means potential negative consequences on other systems or services are not identified or mitigated. This can lead to unforeseen problems, increased downtime, and a failure to meet operational objectives, all of which are detrimental to professional credibility and can have regulatory implications if service availability is compromised. The professional reasoning process for similar situations should involve a structured risk-based approach. First, clearly define the problem and the desired outcome. Second, identify potential solutions, including those that might seem expedient. Third, rigorously assess the risks and benefits of each solution, paying close attention to compliance requirements and established procedures. Fourth, consult with relevant stakeholders, including change advisory boards or security teams, to gain consensus and approval. Finally, document the decision-making process and the chosen course of action, regardless of whether it deviates from the standard process, which should only be done under extreme, documented circumstances with appropriate approvals. This methodical approach ensures that decisions are informed, defensible, and aligned with professional and regulatory expectations.